Welcome to the Clear to Send podcast, a podcast about wireless engineering, where we educate you on Wi-Fi technology, talk about design tips, troubleshooting, interviews, and the tools. Here are your hosts, Roel and Francois.
Today's show is brought to you by Audible. Audible is offering our listeners a free audiobook with a 30-day trial membership. Just go to audibletrial.com/cleartosend and browse the fantastic selection of audio programs. Download a title free and start listening. It's that easy. Again, go to audibletrial.com/cleartosend.
Hey everybody.
Hi guys, so we are back on the Clear to Send podcast here at Cisco Live, and we're going to be talking about 5G here. So I'm here with Roel. Hi Roel.
Hey everybody.
And we have two special guests from Cisco. We have Mike Gaylor. Hi
Yes,
Mike.
sir. Hi.
And we have Pramod Nair. Hi.
Hello.
So Mike, why don't you introduce yourself and tell everyone what you do at Cisco?
Sure. So I'm a principal engineer at Cisco and the security business, and I focus on most things service provider, cloud provider, and 5G falls into that purview. I have the pleasure of working tag teaming 5G with my buddy sitting to the left, and I'll let him introduce himself.
Thank you, Mikey. So my name is Pramod, and I live right in the middle of nowhere in Ireland. Throughout my life, I've worked in wireless technologies. That's 2G, 3G, 4G, 5G. And nowadays, me and Mike are very closely working on the 5G security part. So looking forward to this discussion. Thanks.
Awesome. So here on the show, we talk mainly about Wi-Fi.
Right.
And this is actually the first episode we're talking about 5G. So we just want to, have a quick introduction, overview of what the 5G technology is all about. Just to get to know the technology a little bit more and know how to approach it as Wi-Fi guys. So I saw one presentation here at Cisco Live, and the presenter said that he sees 5G as a network of network. Do you agree with that?
To an extent, yeah. What's happening is that the throughputs, the transports, and the like in 5G are coming very much in line with other technologies that we've used before, Wi-Fi included. So I could see that perspective. I think sometimes we rush to create this network of networks. To me, means that you're going to have the network that delivers fixed, the network that delivers mobile. Yes, they are converging to an extent. And what you're seeing with 5G is taking advantage of a lot of the components of delivering a distributed virtualized infrastructure. So you see a lot of the impact of virtualization in 5G, taking typical, very critical components of what we call the evolved packet core and putting them as virtual workloads in places where it makes sense, because you're catering to a set of use cases, really, which is what I consider special about 5G, is the ability to cater to use cases for things like low latency use cases for IoT, for example, and fixed broadband and other, wired broadband, other cases like this. So I could see the perspective, yeah, for sure.
So talking about use cases, like why do we need 5G? What different use cases did they come up with in the 5G framework?
Thanks. So it's the first time ever in the history of HCA that they have specified a specification for a use case. Okay?
Yeah.
5G is purely use cases led. There has never been any time in the history of HCA that they've ever created specifications for use cases. Usually, the specifications are created for the interfaces, the radio interfaces, the RF interfaces, the core network, and what protocol should be used, mandatory specifications, optional specifications. It's the first time we have the specification for use cases. For example, V2X. What is V2X? V2X is vehicle to everything, and that could include the Wi-Fi transmission as well. It doesn't specify what kind of RF interface should be used. There are some RF interfaces which are regulatory controlled and some are not. DSRC, for example, is not regulatory controlled. It's a shortwave, for example. These are some use cases which are coming up. Another good example would be IoT. Now, IoT is not new. It's been there for long. But here we are speaking about massive IoT. It's not about one device, two devices, or three devices. Exactly, millions of devices. Okay, and here is where controlling those devices becomes very important, and security just became a bit more important thing. So it was always important, but 5G brings in so many different threat surfaces. It makes
security doesn't only become important; it becomes important at ridiculously huge scale.
Yeah.
So now you're taking, instead of this centralized data center running all these controls on bare metal to run the network that's going to run LTE or 3G or 2G before it, now you're having that security challenge of having internet access widely distributed, functions widely distributed to cater to those low latency requirements. So it's a pretty tightly integrated but very widely distributed thing, right? Which makes security a very interesting challenge in that respect.
So talking about scale, what's the effect on spectrum for 5G? I know it's a lot of it's licensed.
Very good point. Very good point. Now see, so spectrum is always a scarce resource. Okay, there is no unlimited amount of spectrum. You can pump unlimited amount of power from the base station, for example, depending upon the country and the regulations. Okay, spectrum is always a finite resource. Okay, the more smartly we use it, the better it is utilized. For example, using LBT, listen before talk, we can use Wi-Fi as well for a higher throughput by matching LTE and Wi-Fi to give a better throughput. Would you call that 4G or 4.5G or 5G? We don't know. But what we are trying to say is that there are possibilities today, and which in many American and European countries, we are trying to use Wi-Fi and LTE together. In some countries, due to regulation, it's not possible. Coming back to your question, 3G will always be there. Maybe in some countries, it might be switched off. 4G will last for quite some time. We've got the CUPS architecture, which is a central control plane, user plane, which Mike just spoke about. All these architecture evolutions will help scalability, and spectrum, as we just spoke now, is a finite resource. The more smartly we use it, for example, using Wi-Fi on specific IoT use cases really helps on reutilizing the spectrum which you have today. So yes.
Okay. So there's a way to do some sort of offload or transition between 5G and Wi-Fi, or how do those work together?
I think it's important to highlight that the transition is the key word that you've used, right? So there's really very little talk, at least as of right now, of people just turning off their 4G infrastructure and running off to 5G, right? So there is as you'll I think you showed in your notes, we'll talk about the two ways to get to 5G. Kind of one is transitional, the other one is a bit more greenfield in approach. But I think it is important. So when you look at the ability to utilize Wi-Fi, as Pramod said, in cases where it makes sense, in certain countries, like for example, where you're in India, we talked about kind of SAMA-based Wi-Fi and LTE and internet lease line as the three access methods, for them, right? And there's a convergence body, there's a convergence motion going there. Yeah, so I think you've got it exactly right around transition.
Okay. So we're not going to see like these competing technologies where 5G could potentially replace Wi-Fi, especially if the 5G technology can pierce through buildings pretty easily or not. I don't know. It's I've seen those kinds of conversations thrown around.
Let's start with.
I don't consider them. I don't really consider them competing technologies.
I agree, Mike. Now, if you speak about Wi-Fi, let's start off from Wi-Fi, for example. Okay, Wi-Fi has been there yesterday. Wi-Fi is there today. Wi-Fi will be there tomorrow. Why? There are so many phones with these kind of chipsets. So many applications, so many things have been made around Wi-Fi. That's very hard to just replace Wi-Fi. Okay, Wi-Fi will be used as Mike also mentioned. It will be a part of the overall technologies which will cater for the use cases. So you will have 4G, you will have 3G, and you will have Wi-Fi as well. Go forward, you might have an enhanced Wi-Fi also coming in the picture for higher throughputs.
So 5G is not a technology per se, it's a set of different technologies used together, right? You could have LTE and Wi-Fi used together
Look, 5G, as per HC, has got its own way, its own RF spectrums, its own modulations, its own defined next generation base stations, which they call as G Node B, as well as a core network, which they call as 5GC. So there's a defined 5G roadmap, but nobody is stopping anybody from using any kind of use cases for a higher throughput and converging that into the 5G architecture.
So you could have the base station, the new base station, and then at the end attach that to like a Wi-Fi for the access.
And no, it wouldn't happen. There might be possibilities going forward, and that is a very good thought. And this is a creative way which people should think. But as per its specifications, there's a separate radio, there's a modulation technique, number of physical cell entities. For example, in LTE, we have got 502 physical cell entities. Okay, in 5G going forward is 1008 physical cell entities. So we are having specific modulation techniques, specific radios for that, but nobody has specified for the IoT use cases. Nobody has specified for this IoT device, I have to use 5G. No. They have specified slicing and things like those.
Yeah, no, I would agree with that. And also, I think we need to remember that 5G is pretty young as a technology, right? I mean, there's a lot of maturity that's still left to happen. A lot of use cases still driving it. So I think some of the stuff, a lot of the things that we're talking about are still relatively formative technologies today.
Very true. Very
right.
true.
So we come back 2 years from now. The conversation could very well be the same, but it could turn slightly as well.
And let me give you a small example, okay? Virtualization came in this world in 1960s thanks to IBM. 1960s. And we are in 2018. I wasn't even born. I wasn't even in liquid form. So in 2000, we are in 30, 40 years back.
1960s, well, exactly. One of us wasn't born. I guess that must not be you.
Okay, we have got all these virtualizations 50 years back, 60 years back. And today, slowly by slowly, we are seeing how to evolve it better. Okay, and we're speaking about 5G. How many years? Nothing, right? So we'll see how far it goes. But as Mike rightly mentioned, it's in a nascent stage, but we have got some POVs already. When I say POV, it's a proof of value, where we have got a core, we have got a radio and beta version of radio, and we're seeing
deployments in little pockets, right?
Little pockets, correct, and to see how it works.
So you talked about the different use cases. I just have one last question related to that. Could you have, let's say you want to design for, or you want to deploy a 5G network for IoT, but also you want to use the same 5G network to support other type of use case? Could you do that, or do you?
Absolutely. Matter of fact, there's a partitioning technology that's. I'm not sure it's exactly new in 5G, but it's become a prevalent part of the 5G architecture, which is assigning either function by or policy by a technique called network slicing. Right. So it's where we can take literally take a slice of the network and dedicate it to an IoT service or dedicate it to a large enterprise. In the case, it's somewhat similar to a policy per APN strategy we had in 4G, but you have functions in the network now. Think where you have different applications plugging into this virtualized foundation, and literally you draw a slice around the different functions to aggregate them and deliver a service. And as I've heard Pramod explain, we have soft slicing and hard slicing. Hard slicing is kind of what I've just explained. Soft slicing is just using quality of service to separate different functions. So there's different ways to go about that. But yeah, network slicing provides you essentially that capability.
Very, very strong point. Just to add on that, the differentiator here in 5G is that now the network has got a capability to tell the device to which slice it should fall on. For example, you will have the radio interface covering your phone, my phone, and Mike's phone. And my phone can have a different profile, Mike's phone can have a different profile, because we too are subscribers who use different kinds of data packages or different volume consumption. Depending upon that, he can put me on a different slice altogether. In 3G, it was purely APN controlled, which is for the entire subscriber base or for the enterprises. Here, it just becomes more flexible. So it's making your life more easy. Networks getting more complex, use case becoming more easy.
Yep. And there's literally a function in the 5G spec and architecture called the network slice function, which helps govern some of that kind of stuff.
So talking about the 5G architecture, we have two big pieces, right? Correct me if I'm wrong. We have the radio and we have the core, right? So how are we going to transition from a 4G network, the type of network, cellular network we have today, to a 5G network?
You want to start?
Yeah. So today we have got 4G infrastructures ready in plenty of the service providers. Now, when you go to 5G, the first thing is, how do you take the first baby step towards 5G? Do you want to deploy your own pockets of 5G, or do you transition from your existing network towards 5G? So how will it happen? As per the HC specifications, there are a couple of options. Those options are called option 3, option 3A, option 3X, for example. Okay, so that is called the NSA, non-standalone model, wherein the control plane, the signaling will follow the 4G, and the user plane or the data volume consumption can follow the 5G. So there has to be an interface between the 4G and 5G, which is called as the XX interface, through which the 4G and the 5G base stations, which is E node Bs for 4G and G node Bs for 5G, would interact between each other and make that happen. Going forward, it will have a standalone model when 5G will communicate the signaling and the user plane to back its own core.
But that's good. That part, though, the standalone part, though, would require either a pretty rapid evolution to what's going on now, or even a new adoption, right?
At least 2 years.
So that's some bit out, right?
Yeah,
so the NSA model is something that we see much closer in.
Correct. Correct. So the NSA, which is the 4G and the 5G, wherein the signaling goes on the 4G and the user plane goes on 5G, that is what we are seeing in the next few months. For example, they will have some beta testing going forward.
So how do you do that? You just put up new antennas?
Yeah. So antenna previously was a purely passive element.
Yeah.
Previously, okay, it used to be a aluminum thing with patterns and the elements, and it'll give you the RF waves. It had no intelligence, no modulation technique, no amplifiers, nothing. Passive element. Nowadays, we see something called as active antennas. Active antennas has got some intelligence built into it, some LNAs, low noise amplifiers or power amplifiers, BPF, band pass filters, band reject filters built into the antenna. Now today we have got those antennas which just needs an extra port to be connected, or through the CPRI cable or through the existing internet cable to activate a software defined radio. So previously we used to have boxes which will have radios. Now it is all the method of software defined radios. So going forward, we might see for the first phase of implementation, which will have a radio unit.
Our show is brought to you by Audible. Did you know you can ask Alexa to read a book to you? I have an Alexa Dot in my house, and I had my favorite book being read to me, Ready Player One. It was really awesome because audio makes great audiobooks, whether you like to listen to books to get your mind somewhere else, or whether you like to learn. Sometimes I like to read biographies. I've been an Audible listener for over a year, and I absolutely love it for my commute. You will too, because the selection on Audible is phenomenal. It seems like every book that comes out in print is also in Audible. So for you guys, you can go to audibletrial.com/clear-to-send, and you can get a book for free right now. Download it and start listening within a few seconds. So again, that's a free book for you guys. Download it at audibletrial.com/clear-to-send.
If those antennas are old, if they have the ports for that specific frequency, then they can just plug in a RF cable towards that antenna, and the RF box will do its modulation, demodulation, and just generate RF frequencies as well. The biggest thing you spoke about is antenna. Now, why is that important? Because antennas are made for specific frequency bands. For example, one antenna can have one port of 900 megahertz, one port of 800 megahertz, one port of 2100 megahertz. But you might not have 5G on those bands. You might have to go and change the antenna as well. So, apart from that, if the antenna is capable of emitting that frequency of radio waves, we can do it today. Okay. If it is a software-defined radio-based active element antenna with a wide spectrum,
new antenna. Okay. And so, talking about frequencies, which type of frequencies will be used by 5G? I know it's dependent on the carrier.
Regulation. It's purely regulation. It's purely regulation control.
Okay.
For example, there are some countries with as low as 26 gigs. Now, 26 gigs can be, it's a like 100 meters, boom, the coverage is gone. Why? Because higher the frequency, higher the losses. For example, 900 megahertz can go up till 60 kilometers, 30 kilometers as well, thanks to the timing advanced GSM. Whereas in the 3G, we see 1800 megahertz and 2100 megahertz, which will reduce the coverage because higher the frequency, higher the losses. Now, when we speak about 5G, there are some countries speaking about 3.1 gigahertz, some countries speaking about 26 gigahertz. So, it all depends upon the regulation, but depending upon the use cases, they will use the frequency band and it will then determine how farther will it cover.
So, in the US, can you give an example for...
I have to check. That's a quality question, all right. Now, because it's not fully finalized, I have to check the.
It's dependent upon each
carrier.
Each carrier
Verizon has its own.
The proof
24 gigahertz. I've heard about 24 gigahertz. One carrier has using lower bands. So like Pramod said, depending on the use case, you have different frequency use. Depending on your regulatory domain as well, right?
I mean, there's as Pramod says, there's regulatory influence there for sure.
Yeah.
And then there's the fact that it's still pretty early on, and there may be some convergence across, but not today.
Yeah, that's a good question, and I just remembered we have some options like for the low range spectrum, we have got somewhere close to 470 megahertz as well. So we have some low frequency kind of options which will help you cover larger areas.
Like rural areas.
For example, you can have one near the coastal area. It needs to cover a specific part. I mean, there is up till only a certain area where the coastal antennas can cover, because after that it falls under the global navigation nautical zone or whatever it is, and that can be one use case. One use case could be for connected cars. Because for connected cars, I don't want to do too many handovers or cell reselections. I want to attach the connection as farther as possible and then do a handover, for example.
Right.
So these can be good.
And then there may be yet a third use case for like a rural broadband, like what you were talking about, right?
Rural broadband, good point.
Yeah.
All right. Another use case I've heard here at Cisco Live was fixed wireless.
FWA.
Do you want to talk a little bit about that?
Yeah, good. So because 5G is now all use case specific, there are a lot of use cases around this fixed wireless access as well. Okay, it's called FWA. Okay, so there are some options where you can provide better throughput or better use cases farther in the rural countries as well. There today we don't have much coverages today, even of 2G or 3G. But going forward, because it is so flexibly deployed using edge computing, for example, we can move this core, this intelligence of the packet core closer towards the edge, and from that edge pull in FWA and provide better coverage in those areas as well. So there are a couple of options, and this is one of those options.
Yeah, what I understood is that everything will become software with the 5G. So you'll be able to move it around.
Correct. Virtualized, correct.
Yes.
So how do you see our jobs as Wi-Fi engineers evolve with the 5G? Do you see us getting involved with the 5G technology, getting involved in the cellular part of the spectrum? Because right now it's been very segmented, right? We have the cellular guys, we have the Wi-Fi guys. And do you see like a convergence in the near future?
Convergence there where we have to know about handoffs or trying to create that user experience?
Very valid point. I'll give you my view and then I'll let Mike continue. So, being an RF throughout my career, in the beginning when I was an RF engineer for 2G, there was an RF optimization team, there was an RF planning team, there was a backhaul planning team, and a Wi-Fi management team, a data center team, and an IP team. for IP networking, things like those. Then towards 2006, 2007, we saw the data center team and the core networking team getting a bit closer, the core team and radio team getting more closer. Towards 2008, 2009, we started to do IP as well. Radio engineers never needed to do any IP networking before. But nowadays, you see a radio engineer needs to be an IP engineer because the network is becoming closer and closer. The same way, Wi-Fi is a very integral part of many network operators.
Yeah,
there are many,
sure.
10 to 15% of their businesses are still managed Wi-Fi.
I would agree, and I think that the line of demarc for where those, the separated Wi-Fi guy from the cell guy, from the data center guy, those lines have grayed substantially, right? Because there are many customers that we deal with where you have sort of an access layer. Yeah. And maybe there'll be some Wi-Fi applications in that access layer. Yeah. There'll be some 5G applications in that access layer. There may be some just straight up lease line fixed applications in that access layer, and they're converging to provide a unified set of services, through a widely distributed data center. So I think the days, to answer your question, I think the days of the Wi-Fi guy are going. I think that skill set is becoming widely distributed. Now, the fact that Wi-Fi I don't think is going away anytime soon means that your skill set is still tremendously valuable. And I think as the Wi-Fi person, I think you're in a position to have to sort of start to learn some of the rest of it, right?
Yeah,
and merge into that.
I'll give you one valuable use case straight away. Today, we speak about handovers. It's called inter-RAN handovers, okay? We can speak about handovers between 2G and 3G, 3G and 4G, and 4G and 2G for cell selection, reselection, and handovers. Now, slowly by slowly, we'll speak about handovers between Wi-Fi. Today, we have Wi-Fi to 4G as well, okay? Yeah. We'll speak about from Wi-Fi to 5G and Wi-Fi to 4G becoming more important because the use cases, they are devices using Wi-Fi. Now, a Wi-Fi engineer now needs to understand how the handover process will take place and how to better optimize the resources of the spectrum, for example. How will he put the parameters? Where will he put the parameters? How to design an architecture which has combined 2G, 3G, 4G, forget 2G, 3G, 4G, 5G and Wi-Fi for example, and how will he get this together? For example, an enterprise guy never had to think about 4G or 5G before. Never. Never. Okay, but today going forward, a Wi-Fi engineer within that enterprise can be of Intel, can be of any from Timbuktu, needs now to understand how will he integrate his infrastructure using the core network towards 3G and 4G or even 5G and do the handover as well.
And it's not only the bleed over in that capacity, it's the bleed over. We talked about network slice before. Well, if I end up dedicating a network slice to an enterprise, a large enterprise or a government agency, well, now all of a sudden I need to adequately protect that trust boundary as well, where the mobile network touches the enterprise. Yeah. And there's all sorts of excitement around handover of function, having calls consistently from one to the other, having identity consistently from one to the other. It's a challenge. It's a big challenge, and that's not going away anytime soon.
One of the big challenges I think we have is that the enterprise needs to engage the carriers so we can establish this sort of gateway so both the Wi-Fi, the enterprise Wi-Fi network is able to communicate with the cellular network, and then we can have this kind of
that is exactly happening in 5G. Now in 5G there's slicing use cases will need certain UPF functions or user plane functions closer towards the enterprise as well. They are not going to buy any slice of UPF, but there'll be certain use cases where the UPF or the user plane function, a 5G terminology for a pure data plane, will be there on the enterprise customers as well. It's called a part of the MEC model, the edge computing model. Okay. So now the enterprise has to work very closely with the service providers for some specific use cases. Yeah. That is where you just became more important.
Yeah. All right, guys. Thank you very much for the discussion. I think we get a better understanding of what 5G is.
It's a lot of information to take in for somebody who's just trying to figure out how 5G is going to come into their plate. But where can people go to find more information about 5G?
Cisco Live.
Well, we have a number of session heats here, We have co-written a white paper on security as it pertains to 5G. We've got some collateral posted in that respect.
Okay.
So yeah, I mean, there's walk around, look around the floor. There's a lot of sessions here this week. Pramod and I are involved in a few of them. There's a bunch more that talk about the different aspects of 5G, security, how the radio evolves, how different pieces evolve. Yes, so there's plenty. And if you're of a standards kind of mind, there's 3GPP.
Yeah.
There's NGMN. There's from a virtualization perspective. There's the ETSI NFV groups.
Okay.
There's a quite a large number of places to go because of how far 5G extends down into the architecture and impacts how widely it's distributed from a virtualized perspective.
Very true, Mike. And we all, when we are born, we are piece of meat. And slowly by slowly we learn and we become some intelligent human beings. The same way, if you have a will to learn something, you will learn it.
Yeah.
And if you need anything, please reach out to us and we are there for you guys anytime.
Thank you, guys.
Thank
you, guys.
Thank you.
Cheers.
for joining
Thank you.
us.
Appreciate it.
Thank you.
And cheers. Have a great day, guys. Cheers. Thank you.